And who's next?
Brian?
Oh, Brian.
And who's next?
Brian?
Why is it doing that?
Oh, Brian. So this one time, everyone is allowed to be licensed, right?
That was weird. Sorry, y'all. And we are good.
Is it Cody?
Cody.
Cody, okay.
I pronounced it wrong for like 3 years.
And you know that all.
Okay, our next talk is going to be Brian Toddy, civil engineering, and mentor Greg Kurtzweiler in systematic human nutrition.
Hi, everybody. I'm going to be sharing my presentation on determining the viability of paper and non-synthetic wax for food packaging. So in 2018 alone, there was over 20 trillion pounds of plastic that was entered into landfills. And the problem is many of those plastics are things like this. So this is what ISU had a cookie packaged in. Now, when you think about this can't really be recycled. One, because it's simply just too small, that it's economically not possible, and the materials in it are simply, it's an unsustainable process of doing so. So we need to find a way to replace this heavy reliance on unsustainable plastic usage. So what I was looking at doing is saying we need to have a paper and wax based packaging unit. This is because paper and wax are both renewable resources. Paper grows on trees. We can monitor how much forests are being developed, how much they're being cut down. Wax itself is also a renewable resource as it comes from bees, and we can process it from trees as well. Including to this, both of these products are also biodegradable. So with these combined, it seems evident that there is a way to combine this. And so the objective of this project was to fully understand the characteristics of the waxes. In order to have a proper package, we need to understand what the material we're using is, how its properties are able to resist things such as water vapor, oil, and other things packages are concerned with. And then the overall goal of this project was to be able to develop a packaging unit that would eliminate the need for polypropylene and low-density polyethylene in food wrappers. And so the production method for the plastics, I don't know if you can't really see the laser pointer really well, but on the left side, what we have here is this is one of the ovens we use. We use containers where we mix different combinations of the waxes. So the 3 waxes I use were beeswax, carnauba wax, and soy wax. We mix different combinations such as 50% soy wax, 50% beeswax, and melt these down. And then what we do is we put them in the laminator, which is the second photo here. And so I'm going to go through this. There's a little bit of a reservoir right here where we're able to dump in the wax, and you have to put it in melted. Simply because the problem with the laminator is that it is a laminator. We do run things through it. So unless the wax is melted when we first put it in there, it starts to leak out. That was an issue we ran into. So we cannot actually melt the waxes in the laminator. Then we can see here is the paper on this side. What it does is it rolls down through here. Right here is a corona trigger. It's not related to the disease, but it's a machine where you do a plasma arc across the surface, and this helps create a better surface for adhering materials to it. And then it rolls over the top. It comes back through the reservoir, and the laminator bars comes right here and comes out. And so with this, we're able to adjust how fast it's going through, so we can see how much, or so we can control how much wax is being applied to each surface. Granted, we ran into issues with this with the different types of waxes because some of them did not like to adhere to surfaces. And then on our end, we made sure to pull out all the material, have it laying flat on the ground, and then we're conditioned for 24 hours before any movement. This was to make sure we did not run into any improvements for cracking or disruption of the wax surface. So when it comes to testing this, we had to understand what makes a good package and how do we test that. So the first thing we did was a cob test. This is a test commonly used in industry to understand amount of water that's going to be absorbed into a paper. And so the apparatus up here is a cob apparatus. What it is you have a flat metal plate, you put a rubber piece, a rubber mat on top of it, put your sample. And so it's approximately a 5-inch by 5-inch sample. The technical specification is, I think, 4.93 inches. This is because it's actually supposed to be in centimeters, because it's asking for a 100 centimeter surface. Except the thing is, you're actually testing a 100 centimeter surface within the color, so the actual size of the paper is a little bit, can have a little bit of leniency. Then what we do is once we put down another rubber piece of the color, clamp the color on it, and you put 100 milliliters of water. I was doing the COB 120 test, so it means that I let it sit for 100 and actually 110 seconds, and then you jump at 110, allow it to sit until 120, and then you roll it between two pieces of absorption paper. And from there, you're able to weigh it, and you take the measurement, the mass before, you're able to see how much water is being absorbed in that time. Then I also did an oil drop test. Like the name sounds, you literally just you put drops of oil on paper. It's a pretty straightforward test. It's a simple pass-fail. In this case, this is a sample of oil drop test. You can see what I circled here. That is a test that failed because you can see that oil was absorbed into the paper and went through the wax. We also did a water vapor transmission rate test. I'll go into that later. Then two other tests we did were differential stain calorimeter. This was so we want to be able to tell if in the wax mixtures we're seeing co-crystallization. So when you're heating up and cooling down the waxes, are they actually bonding together? Are they changing the melting temperatures? Are you seeing this? Are you seeing changes in the properties? This is important to understand. Are we actually seeing individual waxes within the mixtures, or are we seeing combinations? The final test we do is a Fourier transformed infrared spectroscope. So in the COB test, the first test I did was unfolded. This is simply on damaged paper. This is to see if we had just a flat piece of paper with the packaging, how did it behave? So as you can see here along the bottom, a lot of the COB values were between 0 and half a gram per meter squared, except for soy. Soy is a really terrible barrier, and it's just very soft wax. And so what we're finding is that it just simply did not perform very well in this test or the other tests. Something that we need to note here, the problem with COB tests is with the brittle waxes, when you pull off the color, for some of the really brittle ones like carnauba, you tend to get pieces of wax chipping off. This presents an issue because you can't get an accurate weight. That's why in some of the trials in the very end, I only have 1 or 2 measurements because the other ones failed because you were not able to get a good reading. One thing to note is that the paper just by itself completely fails the test. So much water goes through that you can't actually measure it properly. When we go to the COB folded test, so what I did here is I folded the paper into force. This way you're able to see, okay, if I have some sort of fracture along the paper, how does it behave? So you can see here, as you see, in general increase relevant materials, except for beeswax. And I'll get into that a little bit later, but you can also see here, soy wax performs very poorly. And even with the carnauba wax and a mineral oil mixture, all of those increase. One of the good things about beeswax is because it performs so well under both these tests, it's actually really good under pressure and under folding. And that is partly because of how the wax behaves. It's a very malleable wax. And so when it's folded and undergoes different strains, it does not actually break as easily. So for the oil drop test, this, like I said before, you just drop oil on the paper. So for this, it's a simple pass-fail. And one of the things we find here is that the wax mixtures with mineral oil tended to fare pretty well in passing the test. And then also the beeswax and carnauba. What we're seeing here, though, is that there needs to be a strong barrier to prevent the oil from passing through. And that is one thing we need to test further on. In part, it's a little difficult to tell if there was oil passing through due to the dark color of the paper and the wax, but we're seeing some inconsistencies with the rest of the data. And so at least with this, we're able to see general ideas of how it performs under oil. And another thing to note with this one was under a 48-hour period, just gives a little bit longer life. And then we get to water vapor formation. This is one of the biggest, or this is one of the most important tests we did because it tells us how much water is passing through the paper. So what we see with the units here is the permeation values. If you're given a millimeter thick piece of material that's a square meter, it's the amount of water and grams that passes through it for a 24-hour cycle. This gives you your permeation coefficient. So what we're seeing here is polypropylene has a value of about 7 to 10, depends a little bit on the material content. That's the typical range. With beeswax, we've got a value of 15, and low density polyethylene has a value of about 17. So we're seeing that we have a wax that is actually able to compete with plastics. Now, as we go up, we can see direct trends, and as you add permeable wax, you're going to see an increase in the permeation coefficient. As you add mineral oil, you're seeing an increase in the permeation coefficient. The thing with the carnauba wax is what we realize is that because it's a brittle wax, it does not adhere to the surface as well. It cracks really easily, which allows a good, does not provide a good barrier for air to stop it. And I mean, it's a very, when you see this, you can say from the carnauba wax mineral oil mixture pushes about 650, and then we have beeswax, which gets us down to 15. It's a huge range, but it's exciting because we can see that there are materials that are able to compete with different waxes. So in conclusion, what we're able to find is brittle waxes struggle to adhere to the paper. This is what we found with just carnauba wax by itself. We can actually not test that wax because when you put it onto the paper, it curled up the paper and just crushed. Basically creates a terrible barrier. And so because it struggles to adhere, you're going to see you're reducing the ability to resist water, to resist basically things being able to go through the paper and the packaging. Then soy wax and mineral oil both help reduce the brittleness of the different waxes it's mixed with. This was a big issue with carnauba. However, both of these were associated with an increase in permeability, making a poorer barrier. Beeswax consistently performed in both product types. This is important because under both of those, you saw that they underwent different basic surface behaviors. And so we're seeing that they're able to perform under both conditions. And its value with the permeation is very similar to that of polypropylene and low density polyethylene, which is a very exciting problem. Especially because polyethylene and polypropylene are heavily used in food packaging. So this is only the first step. The problem with this is we're only able to get to the point where we're saying, okay, what is an actual material? Or like, can we actually use these materials? So in looking forward, what we need to do is we need to expand our samples. So creating a wider range of these and carnauba wax mixtures. The carnauba is important because it resists the oil, but the bees is important because that's what we found helps create a really strong barrier. Then we need to repeat the testing. We only had one round of tests for the water vapor permeation. We need to make sure that our values were accurate. So we need to repeat that testing. Then we also need to repeat POB, oil drop, and if possible, we need to find a degradation test that we can perform to see are these materials good at being are they good at being recycled and or basically can we provide a way to break them down without having to put them under extreme conditions. This is important because if we want to find the material that we don't use in landfill, this is a key aspect. And then we need to say, what's the limitation? So what we need to get into is say, can we actually use these products? What can we actually use them for? So I'd like to thank Dr. Kurtzweiler for helping me throughout this project. He's been a really great mentor, really helped me learn a lot about food packaging. And I'd also like to thank the ISU Honors Program for providing funding to this project.
Okay, thank you. So what's the cost?
That is part of what we need to look into the next aspect. For this project, we are more looking at can we actually use this? Are these a comparable product? But that's kind of the next thing we're looking at. One of the assumptions we were also working under was assuming that if you look at higher cost food distributors, such as if you want to say like Whole Foods, specialty units, you can probably use these materials as basically as an alternative because you have a group of people who are willing to spend the money on this.
Other questions?
I'm just curious, so, some people have like sensitivities that would in the soil. So would this packaging, could that soy mixture transfer onto the food?
It cannot. So in soy wax, we do not have allergens being used.
Okay.
Granted, food industries that's one thing they try to stay away from is using soy packaging because there's a lot of concerns around that. And so with the soy, that wasn't so much our main focus. We want to make sure we had that as a way to say, okay, here is a variety of waxes.
Anyone else? I got one burning question. Does beeswax have to come from bees? And I'm going to back up why I'm saying that. So you can go to the store and buy vitamins. You don't isolate and purify vitamins from food. That would be very costly. You just synthetically make it. So I think if beeswax can be reproduced synthetically, it's cheaper than we have to have really pollen.
That is not something they went into. That's definitely something we can look at. We were more just saying, okay, we have this product, beeswax, let's just use that for now, but that's something we can definitely explore.
Okay, thank you again. Next up is Maurice.
Oh, well, I gotta pull up. Sorry.
Pull up your thingy.
Mispronounce your name, sorry. Okay, my name is. So this is forward. It's really only when you get that forward. That's backwards. That's a pointer, but this type of screen doesn't absorb the laser, so you can't see it. If you really want to kind of see it, you just have to forward.
Oh, and turn off Zoom for the folks that.
Okay, our next speaker is Maurice Verlaine Delot.
Yes.
In chemistry, and Mr. Angela Shaw, from food science and nutrition.
So hi everyone, my name is Marie Patiki, and I'm presenting on hand hygiene knowledge and practices for college students before and after the COVID-19 pandemic. So before starting my PowerPoint, I'm going to start by asking two questions. Have you ever considered the amount of time that you wash your hands or use hand sanitizer daily? And I have a second question. Have you observed any behavioral change or attitude since the pandemic has started? So I'm going to give you a little bit of background about COVID-19. COVID-19 started in China in December 2019, and it's also known as SARS-CoV-2, originates from the bat and can be transmitted to humans through an animal host. So COVID-19 can spread through droplets and has a low infective dose. So we have two strains, the L strain, which is the more dangerous one, and the S strain, which is less dangerous. So all around the world, we have 4 general recommendations. The first one is hand washing. The second one is wearing masks. The third one is staying 6 feet apart. And the fourth one is avoid crowds. So why hand washing? Why are we talking about hand washing in this PowerPoint? So we're talking about hand washing in this PowerPoint because hand washing can prevent diarrhea. And 9 out of 10 of epidemiology studies have shown that hand washing is really effective against SARS. Also, it can be a really great method to use to reduce the spread of the virus. And as I said earlier in the picture before, we have the soap will break out the membrane, also known as the fatty outer layer. which will make the virus inactive. So let's talk about statistics. Let's talk numbers. So 23% of people are still not properly washing their hands. So in the United States, we have more than 30 million cases of COVID. So for the state of Iowa, more than 355,000. And here at Iowa State, it's more than 2,500. So all around the world, we have like social campaigns. And the goal of this social campaign is to reach out as many people as possible and often. So worldwide, we have the World Health Organization. Here in the United States, we have the Center for Disease Control and Prevention. For the state of Iowa, we have the Iowa Department of Public Health. And here at Iowa State, we have the cycling care. So what's the problem? So the problem in this research, like we found out that young adults lack of proper hand washing procedures. And for the purpose of our research, young adults will be anything between late teens or early 20s. So the goal of our study is to assess Iowa State students' hand washing hygiene based on their knowledge, attitude, and practices before COVID-19 and 1 year after. So before starting, we took a look at Iowa State Student University, and Iowa State currently has more than 30,000 of students enrolled, with 26 who are undergraduate and about 20 years old. So our question is to how do Iowa State student attitude and behavior compare before and after 1 year of COVID-19 regarding the hand washing? So before starting, so what did we do? We came up with a set of questions, which the purpose was to examine the relationship between behavior and hand hygiene technique. We want to learn if Iowa State students spend more time on the hand hygiene technique. The next step was to learn if they had, because of COVID, they had increased the amount of time that they spend on washing their hands, and if the level of awareness regarding food safety, knowledge, and attitude had improved. And more importantly, where do Iowa State students receive public health information regarding COVID? So where are we currently with our project? We have developed a survey tool with a set of questions. We are currently waiting for the institutional review board. And after we receive that, we will test this survey with the small focus group in order to validate our survey. And then we analyze the data using portraits. So for the participants, we will be focusing on full-time Iowa State students from the College of Agriculture and Life Science who are between the age of 18 to 26. So let me give you a little bit of flavor of what questions were asked in my survey. So first of all, we start the survey by asking questions related to demographics, such as gender and range. For the next set of questions, we want to know the behavior regarding the hand hygiene technique after 1 year of COVID. So we want to know more about the frequency and when are they actually washing their hands, such as after using the bathroom, caring for the pet before handling, before eating, because these were the most fun. And also, we want to know the minimum time that they spend on their hand hygiene technique and the frequency about. So for this kind of question, we want to know which technique of hand hygiene are they using daily, either hand washing or hand sanitizer or both equally. And for the last question, we want to know why the Iowa State students receive public health information regarding COVID. So where are we currently with our project? So far we have completed literature review, we have developed a survey, we have been piloting the food of safety experiment. We are currently waiting for an RFP approval. And after we receive that RFP approval, we will pilot the survey to the small niche audience and then develop, collect, and analyze the data to corporate. As I said earlier. So how do ISU receive public health information related to COVID? So here at Iowa State, we have cyclone third, we posted and signed about hand washing. All instructors here at Iowa State are required to put a statement in the syllabus regarding hand washing. We have multiple hand washing stations, bathroom sign, very much reminder, and more importantly, the support of the children student health. So what is the expected result? What are we hope to find out? We hope to find out that young adult population will have increased the hand hygiene technique post-pandemic. And there is more information that needs to be out there regarding hand washing and more campaign on how to reach the young adult population. And we will find out that cyclone care was an effective campaign to reach out to Iowa State students. So what do we hope for this study? We hope to educate and change student behavior regarding hand washing, reduce the spread of the virus among our students, increase awareness about length of time that need to be washing their hands properly. I would like to finish this PowerPoint by thanking my mentor, Dr. Angela Shaw, and the runner of the magnet program. And these are my references and the QR code for more references. And thank you for listening to me. Now I'm open for some questions.
Thank you. Questions?
But why did you choose only surveys in college of agriculture?
So I choose to survey the students in the College of Agriculture and Life Science because they represent about 10% of the Iowa State population.
Others?
Do you think the effect of like the science that we have with our pathways and things like that has worn off over time? You know, like as we see it over and over again, you know, do you think people are less aware of it and, you know, don't necessarily think about it as much anymore?
And I think so far what we hope to find out, and also according to some literature we gave, is like definitely the hand hygiene did not increase because of all those signs around campus. And so like when we're going to see it often, at some point we're going to want to practice it.
Do you expect to see a greater increase in hand washing or the use of hand sanitizer?
For that, I'm not sure, but I think like either or, because on campus we have like hand sanitizer stations, like, you know, in the bathroom as well, and we have hand washing. So I think maybe both of the something that I have to look into.
Find that all the other campuses have a similar communication strategies, I would say, especially like maybe peer institutions that they have the signs all over the place.
So definitely, I haven't looked into other institutes. I just looked into Iowa State because that's the student of Iowa State was the most focused of this.
Well, I had three questions. You anticipated one, you just covered the other one. So my only one I have left is there a way in your survey to build? It's a lot of times you do a survey, people will tell you what they think you want to hear.
Yeah.
You know, like I never wash my hands. So someone admit that, or is there a way you can build into the survey some sort of redundancy, or you just hope that that's just not going to happen?
I think we know that there will be some bias answers,
Yeah.
and we will keep that in consideration when analyzing the data. But we haven't looked into that yet because we just developed the survey and we waited for the IRB in order to look into all these little details with the focus group first, and then see how it's going to impact the greater population.
Great, thank you. Now we've got to apply.
Who was that?
Alexis,
Second.
one of 4 people.
Yeah, for the microphone, should we all stand over here?
Are you gonna be like going on?
One.
No, we're just gonna have to go over there to over here. I just wasn't sure what maybe.
I think you might talk about it.
Yeah, okay.
Oh, yeah, give us a provider streaming. The mics will be able to come.
Okay.
That was great.
Yes, yeah.
All right, our next presentation, we've got 4 people here. We have Alexis Steinhoff in biology, Alyssa Van Steenis in biochemistry, Andrew Dyke in software, and Brandon Smith in psychology and statistics. Their mentor is Elizabeth Strickland in food science and nutrition and food development training studies.
All right, so. Okay, so we did our research on evoking stress reactivity in virtual reality. This is a systematic review and meta-analysis that we've been working on for about a year now. I'm Alexis Steinhoff. I'm Alyssa Van Steenis.
I'm Andrew Dyke. I'm Brandon Smith.
So we see stress environments that are impossible to create in the real world that we can do in virtual reality. So that's part of why we use virtual reality. And we also have a lot of virtual reality studies that are using biomarkers, but we don't see a large enough study population. So doing this meta-analysis, we're able to have more people. And so our goal is to conduct this systematic review meta-analysis of studies that test physiological stress reactivity in response to VR. So the reason why this is important is because our stress response is triggered when there's a perceived threat. And so upon activation of your stress response leads to adverse health effects. It can be emotional, like anxiety or depression, behavioral, like over or under eating, or memory or concentration issues, or physical symptoms like headaches, heart disease, or sleeping problems. And so cortisol is the main hormone in our stress response, and it is believed to contribute to cell death, senescence, and cancer. And so studying cortisol can determine ways to diminish the adverse effects.
So we're doing stress tests, but why are we doing them in virtual reality? There's a lot of advantages. So first of all, there's ethical concerns. So like if we're doing a high-rise stress test, that's for someone standing on a really high cliff or whatever and walking. That could be very dangerous in real life, or it could be, or a stress test could be traumatic if they were putting them in a battlefield with like explosions everywhere. But virtual reality is significantly cheaper on the cost. You will just create it one time, and then you don't have to worry about paying the researchers to administer the stress test or to train them. And there's also like resource costs. So like if you're doing like a firefighting virtual reality, you won't have to pay for the water in virtual reality. Virtual reality tests are also consistent. There's lots of social stress tests where the researcher has to maintain a very specific composure. And the robot is able to maintain that composure every single time in virtual reality. In real life, you might have to throw some results if the researcher can't get it together. There's also other benefits, like you can never have a zombie stress test in real life, obviously. And it's portable, so you could go across the world within a day's time. You don't have to fly researchers anywhere or anything. It's just practical. So like COVID hits, and now you can just do virtual reality instead of being in real life, because we don't have to worry about the spread of the virus.
Yeah, so some of the reasons we did this meta-analysis was last spring, we obviously went online. And so all of the undergrads in our group got to start working on this meta-analysis right away. We went on Zoom and we just talked to each other every week. We got to learn what a meta-analysis was, and we've done pretty much everything from data analysis to writing.
All right, so for the methods of this meta-analysis, instead of the original process that people usually do, is go through each article one by one themselves. We use a process in, a system called Covidence, and thanks a lot to me for facilitate this. By using this program or website, I guess, you can take articles from multiple sources, from multiple disciplines, and streamline them into figure out what you want and what you don't want in your meta. We screened a total of 645 articles of this from 7 different databases, and we got all the way down to 35 steps.
So kind of the method that we use, me, and another undergraduate and I basically started going through the abstracts. So there's a lot of studies to begin with. So we're just looking at the abstract paragraphs of kind of a topic statement and trying to figure out if the study is going to be worthwhile or not. So we looked at kind of like what is a stress task. We have inclusion criteria and exclusion criteria. So it had to be a virtual reality task. It had to have a stressful component. So that can be unpredictability, it could be uncontrollability, it could be social value of threat. All of those things are kind of make up a stress test. We also had to have a healthy adult population. So we didn't want like a VR stress test where there would be spiders. And that's testing on people with arachnophobia. And then exclusion criteria, we can't have any case studies. And computer screens don't count as virtual reality, so we just had to clarify that. And also no dissertations.
Yeah, so to go off of what Andrew said, the next step was me and a graduate student of our group did the full text screening, which was, it took forever. We read through about 200, 300 papers, and we decided based on the inclusion criteria that Andrew just stated, whether they maybe missed anything in the abstracts. We also could tell if there wasn't a full paper present or any of those things. So on the right, all of these are tags that we would put onto any of the papers that would be excluded, and they were the reasons why we would exclude them. And so we had to have the two reviewers, me and the grad student, come to a consensus. And some of the exclusion criteria included a wrong intervention, which would include like a computer screen, wrong patient population, so people that have fear spiders and whatnot.
So the last step for this was the, not the last step, but for the data extraction, we used children's expected data and we pulled demographic, mean age, the physiological information, and then used a separate table for the specific outcomes from their figures. And so that was celebrate cortisol, amylase, heart rate, things that show that if there was a stress response from their study. And then we got 6 to 9 with a consensus to make sure we had pulled the same information and we hadn't missed anything. And then we had originally excluded papers that only reported a number of figures. So these lacked a standard deviation and a mean value that we'd be able to work with. However, we found a separate software that was able to convert some of the figures included in these papers into standard deviation and mean.
All right, so for the results, I think that's very promising. Every single one of these biomarkers, except for cortisol, which I'll explain later, came back to a significant change between the control and the after the stress test. So the VR headsets and environments were very good at what they did. They listed all the biomarkers correctly. But for the cortisol one, which is one of the most important ones for stress, the issue was that prior to the NOVA screening, we didn't have enough papers, not enough information basically to cause significance. But if we, this is the heart rate one. Here's the cortisol one that after we got the NOVA ones, and we haven't quite got to the stage of validating whether or not it's significant or not. But if you go back to the heart one, there is like one of the most common measures. And you can see there's quite a bit of difference between studies, which can be attributed to either the device they use or the task they use. But as you can see, most of them, pretty much all of them, were significantly shifted.
And then so kind of the applications, the results, so like what can people do with this? So there's a really big market for stress training. So if you think about like a public speaking task, you're all fine when you're practicing, but when you get in front of a large group of people and you start reading it, you may not be able to perform it as well as you did when you're practicing. This is because you're not training under a stressful condition. So as we go into the future, we're going to train a lot of people under stressful conditions. So when they perform under stressful conditions, their performance is just as good as when they're trained. There's also like video games that use kind of stressful techniques to basically like benefit their game. And then there's also laboratory stress tests. Like a lot of research still needs to be done on stress, and virtual reality can make those cheaper, more consistent, cost-effective, stuff like that.
And these are the rest of the authors who worked on this project with us.
Here's just some of our very many sources that we use for this paper.
Now you give us 600. You're right.
I know.
Okay, thank you very much. Questions from anybody? I got one question. So I think the public speaking analogy is really good. You know, I mean, whether it's a job interview, whether it's gonna talk, you know, doing it in an empty room, it just isn't quite do it, right? But what about something like somebody has a fear of heights and they want to go over heights, and so you go on a tall building? Their fear is of heights, but it's also obviously of falling. I mean, if they know it's not real, is that, you know what I'm saying? They know they're in a virtual environment.
Based on the studies you went through, it seems like they do. It seems like it's real enough that they actually can get over it based on their VR.
There's also some studies who use an augmented reality, so they also have an in-person aspect. So like for heights, I'd be standing on a short beam that's about 1 inch tall. So you're standing on it, so it looks taller than it is, but you still feel like you have that height and you're not on solid ground anymore.
It's very likely that there's going to be a future like emerging therapy for electricity. And yeah, it seems like the emerging right now is at high enough number you can at least see that the result of stress reaction, but in the future, and probably very near future, can be a lot better. Just
So you guys have seen a bunch of academic papers about VR for stressful environments, like in universities, studies. Do you see any examples of like industries of this or the military using this technology?
So I'm actually on a different paper right now that we are basically using stress training to train astronauts for the space station. So the goal is to put a fire out on the space station. So we're testing it on non-astronauts right now, but yeah, it is very active.
Some of our papers included like firefighters, police officers, and I think we had some military members as well. And so we were able to use some of those when we had a healthy population as well that were included in those groups.
there are studies that treat PTSD. It was sort of like an audience. I was just thinking of actually being a car and the audience, or outside, to help them get over the split-second reaction to it. So,
Is there a negative, like if you're training somebody out to be really, really good about it and not get stressed out about it?
there were a few tasks that train people, not really train them, but saw the reaction to involved. So and also dates as well. So I would assume that's probably the same method, I guess, but I'm not sure who would do that.
Plus the activity, even walk with it. Yeah. All right, thank you.
Is yours gonna be online or offline? Oh, online, okay.
Is it? It's for the online development. It's so close.
What's your last name? Shelby? Okay, that's the last one. Sorry, it's being slow.
for the schedule, so you can have 35 minutes.
Okay.
What was that?
All right, I think. Oh, wait, hang on. Thank you.
All right, our last speaker is Celeste Chadwick, food science and French major, and her mentor is Maria Acevedo in food science and nutrition.
Hi everyone, my name is Celeste Chadwick, and my presentation today is titled Beginning Chemical Diversity of Skeleton Biogels using Differential Chemical Modernity. So first, to provide some background for all of you, I wanted to look into what is a gel. So I have three images showing here on the bottom. The one on the left shows a jello pattern, the middle is a gem, and then the bottom right is Vaseline. These are all examples of gels. The one on the bottom left, jello, is the most solid-like in structure, and then the Vaseline is the most creamy. There's a lot of variety in what a gel can look like. So a gel is characterized as being soluble with a semi-solid structure. And then common structures and looking at food gels are going to be polysaccharides and proteins. And then they're held together by weak intermolecular forces, the van der Waals interactions, and then also permeability interactions. And then these can be further characterized using rheology to get a better sense of elasticity or just this response under stress. And looking at our first part of the biogel, this is the hydrogel, which I'll be calling H2 for this presentation. This is a picture of the hydrogel on the right here. You can see it's pretty clear in color and it is pretty solid in structure. These are applications for the food industry, the cosmetic industry, and then also the pharmaceutical industry. And then in the case of this gel, we use gelatin for the structuring for the compound getting this gel structure. There's two phases for these gels. For the hydrogel, the phase is the continuous phase or the liquid phase, and then also the suspension phase or the solid phase. So in this case, we have gelatin being the structure of our solid phase. And then the properties for the hydrogel are its good spreadability, it has a hydrating effect, and then also a cooling effect on the skin. And then given that it is water-based, it's also going to be a polar molecule and have hydrophilic properties. This is the next part of the biogel, the organogel, or OG for this case. This can also be described as a polio gel because the gel phase here is edible. Similar applications for this one, applications to the food industry, cosmetic industry, and pharmaceutical industry. And then in this case, we have the continuous phase is sodium oil, and then our suspension phase or our solid phase is restaurant wax. And then the properties here, given that it's oil-based or that it's sticky, it's oily, has a moisturizing effect, and it also prevents water loss. And then given that it's oil-based also, it's going to be apolar or hydrophobic. And this is a picture of our completed biogel product. So I'm including the image of the 60-40 concentration on top with our stabilizer iron, and then also the 70-30 concentration on the bottom. That's going to be 60% organogel to 40% hydrogel. So for the combined biogel product, when you combine the organogel and the hydrogel together, it's also going to be a combination of those two phases. So water washability, spreadability, a moisturizing effect, and then also the added benefit of being both hydrophilic and hydrophobic. And then looking at the images further, so the two images on the top for the 60-40 concentration appear to be brighter white than the ones in the bottom in 70-30 concentration. And then also looking at the consistency, it appears to be a bit smoother in the 60-40 concentration and then a bit smoother in the 70-30, and also a little bit less monogenic as well. And then further looking
looking at hydrogels, there's many benefits to creating hydrogels as opposed to looking at just hydrogels or organogels. The first benefit is that when compared to other hydrolyzed gels such as gels, springs, and hydrogels, they offer more stability. This is because the two phases, the organogel phase and the hydrogel phase, are both relatively stabilized structures. And then also they have both hydrogel and hydrophobic components. And there's many uses in different industries for these hydrogel products. There's also a lot of variability in how you can make them. So I mentioned how to make ours in this project. There's also many other possibilities you can use to make these hydrogels, just based on the physics purposes and what you want to do with them. And then they're also more desirable than just pure hydrogel or pure organogel or real gel. They have higher consumer acceptance and improved flavor, and then also higher protein content. So the purpose of this presentation was to explore the thermal properties of these hydrogels while varying the amount of emulsifier used, and then also while varying the ratio of organogel to hydrogel. And then we hypothesized to see an enhancement of the thermal properties of the hydrogels, particularly when they use higher amounts of stabilizer for the hydrogels. And then this slide here just shows a very simplified version of how we make these hydrogels. So we treated both the organogel and a hydrogel separately. We had the hydrogel on a hot plate and then just melted the gelatin into it. And then for the organogel, that was made separately in the oven. And then we combined the two under a homogenizing. And then looking at our research methods, the main tool used was the differential scanning calorimeter by the company Permeation Instruments. The image in the top right shows the exact model that we used. And then the principle of DAC is that we have two bands shown in A and B on the bottom right corner. And so sample A, for example, would have our sample A. So for this, we use between 3 and 5 micrograms. And then sample B would be our reference band. So there's no sample added to the reference band. And then the machine is able to measure the difference in the temperature and the peak flow rate going to both of these samples under a certain temperature controlled program. So in this case, we did a temperature from 0 to 9 degrees Celsius for the rate of 2 degrees Celsius, 10 degrees Celsius per minute, and then equilibrated and then held it for 3 minutes. And then we cooled it back down to -6 degrees Celsius at a rate of 2 degrees Celsius. And then this was done 2 times through just to look at the stability of it and then also kind of reversibility of it. This image I just showed briefly a little bit earlier. I showed it here again in large to get a better sense of like how the gel looks inside. So the small images on the bottom show inside views of how these hydrogels actually look, and then gives you a better sense for the homogenization. So in these 2 samples here, there's no phase separation observed. It looks relatively well. And then you can see again, the 1-to-1 ratio or 50-50 ratio shows a greater weight, 60-40 ratio shown on the right side. And it makes sense because if you have more organogel and more oil-based component going into it, it's going to be more relevant for it. And we're going to the result section next. So these first 2 graphs here, graph A and B, show the heating from 0 to 90 in graph A, and then the cooling from 90 to 0 in graph B. So the main thing you see here is there are 2 distinct peak patterns. So they're kind of hard to see, but you can kind of see them in here on the yellow a little bit. We have the peak occurring around 3 degrees Celsius, and then a peak occurring around 7 degrees Celsius. And then you can see them very clearly for the western wax peak on the top, and then the gelatin peak on the bottom. But the one occurring at lower temperatures is part of the gelatin phase. And then the one occurring at higher temperatures is part of the western wax. So what we're seeing here with these 2 peaks is that it's showing that this is a true biphasic system because these 2 peaks are happening. So even though we combine these 2 phases together to make our hydrogel, these peaks are still present here. And then also the gelatin peak, like I said, is kind of hard to see. However, if we use like another system like IR to further characterize this, the peak is, we are able to see that it is happening independently for a stabilized system. And then looking at these graphs here, these show the freezing temperatures from 0 degrees Celsius to -30 degrees Celsius. So looking first at the green or gold peak in graph B, that's the 60-40 control sample. And then comparing that to the yellow line in graph C, the 70-30 control sample, there is no stabilizer either to those samples. We see one clear large peak for the 60-40 control, and then we see a bunch of smaller peaks for the 70-30 control. So this is showing the physical water in these samples as it's freezing. So it's freezing all together at the same time for the 60-40 control, and then at a bunch of different places for the 70-30 control. So this can be explained in part because of the freezing version happening between 60-40 and 70-30 concentrations. So as this is happening, it's disrupting our system and then causing a water to specific points in different temperatures. And then looking then at the 60-40 1% concentration, the red line in both B and C. Comparing 60-40 to 70-30, we see a similar effect there. So freezing version is happening once again, disrupting our system and causing the water to freeze different points. And then also, the addition of adding stabilizer at this point too is causing, is adding more molecules to the system, which is causing an overall depression of the freezing point. And then this table here just shows the same thing I just showed you guys, but in numerical form. You can kind of further see, especially for the gels and peaks, you can start to see on the graphs what's happening numerically. So the first column, the 2 solar organogel, that shows the melting of the rice grain last week. So we saw in the graph there was a very little change to that peak as we added stabilizer. And then looking at the hydrogel peak, we could see a difference. It was kind of hard to characterize in the graph because you would see this one here. So we see that as we add stabilizer, looking at the 60-40 control and then 60-40 1%, the temperature is decreasing in the T-gel and hydrogel. So it's showing that this is happening more readily. So adding the stabilizer is actually enhancing this process, making it happen more easily. And then looking at the final column for the freezing of water in the sample, you see a similar effect like the graph showed earlier. So just like as you add stabilizer, you add in molecules to the system, disrupting the system, thus causing overall depression for the system. And then a similar thing here showing the entities, which is a similar trend. So once again, little to no change on the original phase. So then there is a phase on the hydrogel and the freezing of water. So this is the same results here. As we add stabilizer, you see installation of gelling happening more readily, and then also a depression overall of the physics. So then to conclude, we do definitely see that the stabilizer has an effect on the hydrogel system. The most obvious effect can be seen for the freezing point of water, which is going down as you add more stabilizer. There is a freezing version happening between the 60-40 and 70-30 concentration. Again, you can see that from freezing of water changing and having more peaks present. The 70-30 compared to 60-40 concentration. And then this also shows a harmless for applications in industry because of their enhanced thermal properties and overall stability. And then future research can be done later on to further explore the use of adding other stabilizers, and then also the effects of other ratios, such as the 80-20 ratio. So this is an interesting ratio because it can be used for different saturated fats in certain products. This higher amount of organogel is more desirable for these products, given the higher fat content and higher oil content, and a more low amount of fuel as well. This can be used as well for topical drug delivery, given that it's both hydrophilic and hydrophobic. And then similarly, it can be used for antibiotic compounds again, given that it's antipathic and also it has a semi-solid like structure. And also it's fairly resistant to separation over time as well. And then finally, thank you to the Food Science Department for making our programming and then the cycle.
Thank you. Questions? I'm gonna go back one slide. So I think you could get together with our first speaker, I think. Saturated that with my house. Yeah. Question, do you get topical drugs? So is there a use for these for some sort of like oral drug delivery?
So I think we're looking mostly at topical because it's so frequent, it could be as like as a cream, transdermal.
I was thinking you like encapsulated it.
Oh, we haven't done it, but there are findings that do encapsulation of with vitals.
Okay.
So I
And
think
so you can put something in there.
probably,
Yeah. Other questions? All right, thank you all.
But we are not streamed right now, so
I think we are.
no, I think Julie is activating it.
Oh, I see what you mean. We're
Yeah,
not.
Julie is activating after she sees that students are ready, you know?
Oh, okay.
Yeah.
I didn't know that. I just did what I was told
Mm-hmm.
and went on with my life.
I'm pretty excited with that. So we've done in 2 weeks. So.
It's, I know, this is gonna sound bad, but like, I love it. I think you're really gonna like the atmosphere. Oh, yeah, you grew up
Yeah.
here.
Yeah.
Wait, so is your niece only 3 months?
Yeah,
How do you
so,
find that?
there's,
Because we're looking for something like that.
so, this is what I meant to do is, the guy I found on Craigslist, he just
Oh, for real?
get a person to move out.
Oh, so
right?
it's a sublease. I
No,
got it.
it's actually not selfies. Yeah, it's a 4-month lease.
Oh, so the person broke their lease.
Something like that, or their lease ended and they're like, and the guy said, yeah, you guys not able to rent to people until the fall when our students come
So,
back."
yeah.
Yeah.
That's, Trevor and I are literally looking for somewhere we can pay month to month or
Yeah,
quarterly.
it's lucky because basically all the places I found on month to month, it's expensive.
Honestly, 7.
Yeah.
My studio was like 690.
Yeah, and I think I wasn't gonna be able to get, I figured if I stayed under 900 total, I'd be pretty good.
Yeah.
Plus, I'm only making way more than that. It's not a concern for me right now anyway.
Yeah, what are you gonna get paid? Are we being live streamed? I'm so sorry.
I'm getting 18 an hour, but they said that they said I'll be typically working 5 to 10 hours over the 10 week.
15, you said?
18,
18.
and then 5 to 10
That's exactly what Trevor got his first,
overtime.
whatever
Yeah.
this is called.
And then, and I'm looking at doing with overtime, everything, probably about 2,500 to 3,000 a month. Which I mean, for my living costs. Going to, I figured total, I'll be like, for total, like everything, I'll be about 900. And just everything. Yeah.
I feel like you'll be fine.
Oh, yeah, no, I've got a bunch of things like that anyway, so I'm not even concerned about cost of the fall.
That is one thing. Sorry, I'm trying to be careful what I.
No, because if I didn't have a job this summer, I could still, like, if I didn't get paid this summer, I could still do this internship, live in Des Moines, and go to school for the fall, and still come out with money. So,
Really?
yeah, I had no money.
Nice. And you don't need any help or anything?
No.
Not that that's, you know,
Yeah, no, I'm really lucky. Granted, also customers.
yeah, I was actually just gonna say that. Let's recognize Hanson, Julie Hanson.
Yeah, they're not gonna be here today, I guess.
Okay, that's fine. The PowerPoint's not here.
Picture of their video.
That is literally why I asked.
Okay.
Okay, yeah, no, it was good to see you. Let's have like a 30 day outside.
Yeah.
Yeah.
Okay.
Bye. What?
You take a picture of us.
Yeah, how do you know my name?
Oh, we're being fine. Yes. Would you mind taking a picture with me consent, so I can send it to our PI? Okay.
I mean, no, I would.
Okay. And there's no moderator. Okay. Oh, okay.
Are y'all just one group?
Yeah. Are we the only group?
I guess so.
Oh, cool.
Oh, that's the word just asking you.
Cool. Anybody know that? Community? No? Okay, got it.
Oh my goodness, I watched that, oh my goodness, what's that community? I started it with some friends.
And your kinesiology, right?
It's like for honors. So there must be like a honors person. Yeah, well, you don't have to be an honors speed research, but to be an honors, you have to have. Yeah. They have it.
All right,
I'm just
where would
making sure
be
it's
a
working.
Good place for me to sit.
Wherever you want.